Hello all, I wanted to do a brief tutorial on improving the robustness of angle parameters in Revit families. This was a frustration for me when I first started in Revit, and I just wanted to review it with anybody else who might be starting out and encountering this. Certainly figuring out how to control a parameter for an angle is a potent a potent ability to have in Revit, and not being able to is, I just felt really hamstrung when I couldn't. So anyhow, I'm going to start by showing my traditional understanding of how one would do these. You start with a generic model family. I'll use as just kind of a basic starting point. And of course, for angle parameters, we're taught, at least one methodology is to use a reference line. One constrains this to the origin, and then one introduces a angle dimension to this. One can select that and assign very simply an angle A. And just to complete the constraints, I will select this dimension as well, excuse me, and we will give that a dimension R. And the kind of classic examples that you see here are that you can flex this, of course, to 70 degrees and see that it goes there. Your radius, of course, is flexing as well. And you can push it over the boundary of the first quadrant and into the second quadrant, and you're able to get that to perform, and you can come back to the first quadrant, and that performs. And then we get a little more adventurous, and we say, well, let's take it to 210 degrees. And we push that. And now we get this constraints are not satisfied. Despite the fact that it does rotate it, if you try and put it back into the first quadrant, the family is effectively broken. I'm going to show another approach that is similar, has a little bit more complexity to it, but does have more robustness in its behavior, and I think is worthy of examination. So we'll start again, this time with a generic model family again. And we will create the same two initial parameters. We'll create an A parameter. We'll make sure that that's an angle. And we will create an R parameter. We'll have that be a length. In addition to that, we are going to create two other parameters, an X component parameter and a Y component parameter. This was my recollection of my early trigonometry lessons, and thought that I was going to basically create an X component and Y component, have a reference line essentially snap to the intersections of some reference planes, and circumvent this issue. I thought I was being really clever. This first illustration is going to show, I regret to say, a failed, some constraints to it that don't make it a worthy alternative. But it is a building block toward the more advanced technique that I think is better and is worthy of sharing. So anyhow, we have these two first parameters, the 45-degree angle and the 5-inch radius. The X component, if one recalls from one's trigonometry class, is going to be R times cosine A. And just to spare yourself some typing, I'm going to copy that and duplicate it here, and we'll just change that to sine for the Y. And you can see we're getting our behavior here that seems to be doing okay. We can add 6 inches, and we apply it. I'm sorry, I need to do some drawing first. So I'm going to put a reference plane in here, a reference plane in here, and recalling those variables that we just created, I'm going to put 2 dimensions here, and we're going to call this the X component and this the Y component. I'm going to have to zoom in a little bit here and change the scale so things are a little more legible. And I will take now our reference line like we did in our first family, and I will draw it again. And this time, instead of having the angle parameter explicitly called out, I'm funneling it through these two X and Y components. So it's implicit. It's not explicitly stated in this family. It's stated basically through these two components. And I'm going to lock this down. All right, and I'll pull up the parameter values, and we will change this to 60 degrees. I will apply it, and you can see it's behaving itself. And now you know, we can even flex this distance here, and everything is behaving itself. But now you'll notice that this one doesn't even go into the second quadrant. Okay, and that immediately breaks. So you know, one can throw in the towel here and basically say, well, this methodology doesn't work. But if one really analyzes why this isn't working, basically the only thing that's failing is the fact that Revit has a problem taking a reference line that is constrained to another reference line by a parametric value and switching its orientation. So, you know, if we take this line, this reference line that's flexing, and we move it to the other side of this line, that just rocks Revit's world, and it, you know, doesn't really want to deal with situations like that. So the way we address this is to basically look at the full gamut of values that exist for this component. And in this case, the X component is going to flex to both sides of what essentially is a circle of radius r here. So to get around that, and the same is true for this Y component. This Y component is going to go in its extremity in the positive direction up to r, positive r on the y-axis, and in its extremity in the negative direction down to negative r down here. So what we're going to do is put another reference line here and another reference line here, so that all the values of the X component and the Y component, when we transform them, and I'm going to delete them now, are essentially referenced off of this this other reference line that is off to the side of the full gamut of values for each of these parameters. So I'm going to create another dimension here and another dimension here, and both of these dimensions are going to have a value of r. Now we're going to come back in here, and I want you to take a look. We haven't changed the location of this line at all, of this, you know, this reference line or these two reference planes. We've just deleted those earlier dimensions of X component and Y component here. What I'm going to do to that X component value and that Y component value is simply add an r to it, and then reference those same X component and Y components off of these two lines now, instead of the two reference lines that go through the origin. So let's try that. I'm going to come in here, and I'm going to take this, and I'm going to say r plus. I'm going to go back to here and say r plus. So now both of these values have been increased by the radius of the circle. And I'm going to go into here, and I'm going to go here and reference that X reference line, and then go here and reference this Y reference line. These used to correspond to the X and Y component, and I'm going to make them correspond again, this time off of this lower intersection. So I'm going to take, I'm sorry, I need to do this singularly. I'm going to take this and change this to an X component, change this to a Y component, and notice that they're not changing position because we've simply shifted their reference location. The values are staying the same for this actual point in space. Now I'm going to go here, and we're going to try pushing this again. We're going to push it to 120 degrees. It works. Now we're going to push it to 210 degrees. That works. We're going to push it to 330 degrees, which puts it all the way into the fourth quadrant. And you can see that now if we want to bring it around again to 70 degrees, we can do that. Now, this is not without its issues. If you start to do you know, extrusions and paths that are locked to this constraint, you will still run into buggy performance. And I don't want to, you know, oversell the virtues of this. It is basically my experience in Revit that every situation has you know, techniques that need to be implemented for it, and it's been my experience that this particular technique is one that does build robustness with things like door swings and the canopies on a carport. You know, anything where you've got some inclinations that might need to go beyond 90 degrees. You know, I have run into situations where using the cardinal values like 90 degrees you know, will break an extrusion that's linked to this. But you can see that even this even if we go to 180 degrees, even that performs. And so, it does have some robustness. I've had to work with families where I've built some conditional statements to work around some of the bugs that I've encountered when using, reference lines that are, perfectly vertical or perfectly horizontal. But this at least is one way to build some robustness in the basic flexibility of an angle parameter. I hope that when you're using angle parameters in the future, you might consider tapping some of your early trig classes to increase the rigor of the performance of your Revit families. Thanks a lot for watching,